152 million years ago, a volcanic eruption changed the Earth. Eruptions from the Siberian traps released enormous CO2 and methane. Ocean acidification, anoxia, and global warming caused the extinction of about 96% of marine species. This was the most severe biotic crisis of the Phanerozoic. The Siberian Trap's large igneous province covered millions of square kilometers. Magma from deep mantle sources erupted continuously for hundreds of thousands of years. Eruptions released enormous quantities of carbon dioxide, methane, and halogen gases. Methane from heated permafrost or seafloor hydrates likely amplified the greenhouse effect. This geological event, through cascading atmospheric and oceanic chemical changes, reshaped the entire planetary biosphere. Late Permian oceans hosted rich invertebrate communities, including brachiopods, ammonoids, and reef ecosystems. Rapid atmospheric CO2 increase lowered seawater pH and reduced carbonate saturation. Many calcifying organisms struggled to form or maintain shells and skeletons. Weakened ocean circulation and warming expanded deep water anoxic zones. Toxic hydrogen sulfide accumulated. Many benthic organisms went extinct. Acidification, anoxia, and food web collapse triggered cascading extinctions. Brachiopods, bivalves, echinoderms, and many fish disappeared in large numbers in a short interval. Marine ecosystems underwent structural collapse across the Permian-Triassic boundary. Survivors were mostly small, tolerant taxa. Recovery took millions of years. Terrestrial ecosystems were also highly differentiated in the late Permian. Synapsids, herbivorous periasaurs, and early archosauromorphs coexisted in forests and plains. Land also suffered extreme heat, acid rain, and drought. Many large terrestrial tetrapods disappeared rapidly. Forest cover collapsed. Marine invertebrate extinction rates reached approximately 96%, far higher than on land. Entire orders, such as ammonoids and some groups, brachiopods, and trilobites, nearly vanished. Survivors were mostly small, stress-tolerant disaster taxa. Early Triassic ecosystems remained low diversity for a prolonged period. The Permian-Triassic extinction was the largest and most profound biotic crisis of the Phanerozoic. It reset the structure of marine and terrestrial ecosystems. Survival pathways were highly contingent. Global carbon isotope negative excursions, anoxic black shales, and volcanic ash layers extinction was strongly selective. Small, tolerant, metabolically flexible taxa were more likely to survive. The loss of large, specialized forms reshaped subsequent evolutionary trajectories. The Permian-Triassic mass extinction was the most severe test Earth's biosphere has endured. The volcanically driven multi-factor cascade reset the biosphere, yet survival and recovery pathways were full of contingency and path dependence. After the mass extinction, ecosystems remained simplified for a long time. Survivors opened new evolutionary space. By the mid to late Triassic, dinosaur ancestor lineages began expanding into terrestrial niches. Mammal ancestors retreated to small, nocturnal lives. Global History, Episode 008, Dinosaur Hegemony and the Marginal Survival of Mammals.